working on the transom, and this had twin engines, okay? Bert did the right thing. He used dowel material, wooden dowel, and with epoxy, he went ahead and he closed these in. He was about ready to actually fair this. He also removed a couple of scupper drains so that we could paint the boat. But here's the issue. After he removed a scupper drain, and I'm going to do the same thing he did, he kind of poked his finger on the inside to the core material, and take a look at the problem. We have rot. Okay, this boat's going to be going to a really good charity. We cannot, in good conscience, let this go out to the public with a rotted transom. So we're going to change directions a little bit. We're still going to paint the boat, but we have to first put in a new transom. And what's so special about today's episode, guys, is we're going to show you a completely new material that you can use for transom core material. Now, we're going to be doing a lot of glass work. We're going to be doing a lot of fairing. We're going to be doing a lot of changing. And what I'm talking about here is, guys, do you see this big splash well right here? It's about 2 feet in thickness, and it's completely unusable space on the boat. We're thinking about, we have to cut it out to get to the transom. Why not change things? Maybe we could extend the deck out to the transom and give us a whole lot more usable space. I used a combination of cutoff wheels and sawzalls in order to kind of score all the way around the perimeter of the splash well. And then we had a couple of access holes in the middle that we used with a brace and a cherry picker to kind of get a little pressure on it until we could get it to release and get it out of the way, which would give us access to the rotted transom. Now, with a combination of tools, the guys went ahead and they just plowed out all of that rotted wood, and we're now back down to some glass. And I really want to get into a new composite type of material that a lot of boat builders have been using for about probably the last 16 years on transom material, which leads us to our next expert guest. He's right over here. This is Andrew Brown.
Hey, John.
And hello. Andrew is with BoatOutfitters.com, and we're now up at your factory in Ocoee, Florida. And boat builders have been using what product instead of wood in a lot of the popular model boats now for transom materials, for stringers, for decks. What's this material called?
Well, John, it's called Coosa Board, specifically Coosa Bluewater 26.
How is this Coosa board, how is it different than plywood?
Sure. So it's a high-density polyurethane foam that's reinforced with woven roving and continuous strand fiberglass.
Okay, so there's layers of woven roving fiberglass. We've shown that before on the program, guys. It's sandwiched into polyurethane foam. And then it has continuous strands of fiberglass throughout it. That's what gives it its strength?
It is, yeah.
It's very lightweight in comparison to plywood. How much lighter is it?
30 to 40% lighter than plywood, and the water absorption rate is the other major advantage. The water absorption rate of Coosa board is in the area of 1%, whereas plywood would be in the 20 to 50% depending on the quality.
But because it's composite, it's not organic. Even a tiny little bit of water, that 1%, isn't going to rot this.
You don't have rot, you don't have mildew, you don't have any insect-related issues with the composite material.
Okay, what are the different thicknesses that Coosa board comes in?
Coosa comes in 1/2 inch, 3/4, 1 inch, 1.5 inches. You can also sandwich different material thicknesses together if you have a unique thickness you're trying to achieve.
I want to talk about how wide my transom is. I'm thinking we could get away with a 96-inch long piece of Coosa board, and how big do these sheets come in?
Sure, so Kusa is typically shipped in 96 by 48 sheets, so your transom just barely fits in a single sheet.
Whoa, a lot of boats might be a little bit wider than 96 that have a rotted transom.
Right.
They might want Kusa. What do they have to do?
Well, like you say, there's a lot of people with larger transoms, so what you do is you can certainly seam it. And when you seam it, the recommendation is to do a puzzle piece joint, which will make it much stronger than just a standard lap joint. But this is something we do regularly that we could certainly do for customers.
I do want to talk about bonding. Okay, can you bond in Coosa board with polyester resin?
Absolutely. All standard adhesives will work perfectly with Coosa board.
What if I had the guys like on our transom? What if I had some like little pieces of door skin with a hot glue gun, and I had them kind of make the shape of my transom, and we got it here? Could you digitize it and then have it cut on the CNC machine?
We can digitize the template. You know, and oftentimes we're doing that depending on the complexity of it. Sometimes a hand sketch or a drawing works just fine as well, but we can certainly cut it to any size or shape that you require.
Okay, and this could be used in transoms, this could be used for rotted stringers, this could be used for rotted bulkheads, this could be used for replacement on rotted decks. And this is the new stuff. This is what the boat builders are going with. Well, I see all of our clamps are in place for clamping the top side of our new core material for the transom. Just to bring up the speed, Bert went ahead after all the rotted wood was out. He ground the left fiberglass, okay, the original fiberglass, both on the transom, going up the hull sides a little bit and down into the floorboard. And back behind me here, guys, this is the Coosa board, 1.5 inches thick, that our friends at Boat Outfitters cut out to the exact shape that we need using their CNC machine, and we could spread that material over the original fiberglass. Everywhere that we're going to be glassing to, we want to make sure that we have a coat the resin on. And in a bonding situation, guys, you do want to have something to where you have some tooth going back into the original material. And that's what this fabric right here is for. This is called 1.5 ounce fiberglass chop strand mat. And this is a cosmetic type of fiberglass into all of that resin, and we want to make sure that there's no air voids. Now, this is not structural, okay? This is cosmetic. It's just giving us tooth. Where our structure, where our strength is going to come into play is with this material right here. This is called 1708 knitted biaxial fiberglass cloth, and it's both sewn and it's stitched in multiple directions. And now that we have some mat into the boat, some fresh mat into the boat, we're going to laminate it sewn and cross-linked way in. We're going to lay this into our fiberglass chop strand mat. Now on the back side of 1708, you again have fiberglass chop strand mat, some tooth again to bite into. Now once we get the 1708 in and all the air bubbles out there, we're going to have to wet out the Coosa board, the face that's going into the transom, and we're going to very carefully get that into position. Now here's what we're going to do differently that we haven't shown before on the program. We're going to clamp this with a single screw going into that fiberglass stringer. We need a base clamp. We need some pressure on the bottom part of this Coosa board. And with a thin piece of just some scrap plywood, we could go ahead, we could put this down at the base, and with a hammer we could kind of tap this into place, giving us really good spread out pressure loads from both of those stringers. We get some good base clamping on the Coosa board. Now for the midsection of the transom, we have an original bulkhead down below deck that we could brace off of. We also have a flange on where we cut out that splash well, okay? And we could use some bracing there. Now for the top part, we got to clamp everything evenly. We're going to go ahead and we're going to clamp all the way along that transom at the top level. Now once that cures, and it's going to take overnight, we'll come back the next day and we're going to put in some more structural glass. The 1708 knitted biaxial, but this time we're going to be putting it in mat side down onto the Coosa board, where our woven pattern and our stitch pattern is on the outside. And we're going to come up the hull sides a little bit. We're going to go down into the floorboard a little bit, but we're going to do a double tab. We're going to take some 1708 knitted biaxial cloth, and we're actually going to kind of reinforce the entire perimeter of that transom with some 1708, and the combination of glasses that we chose is going to be stronger than it first came out of the factory back in 1989. The structural part of our transom replacement is complete, guys. What we have here are double tabs. This is 12-inch wide, 1708 knitted biaxial fiberglass, tabbing from the transom to the hull side. Also, we double tabbed it going down into the floor. You want to make sure that your glass has continual lamination, and that's what a fillet is going to provide you. We have our 1.5 inch Coosa board now in place. We have good squeeze coming out. Remember we showed you kind of how to clamp everything? This is just 1708 mat side down into the Coosa board, fit side out, and I am telling you, this thing is rock solid.